Hey everyone, welcome back to How AI is Built. So today we're gonna hit Rerankers. I didn't want to go into the basics behind Rerankers in the upcoming episode, so I want to give you some background right now. If you don't need it, or if you just want to go into the meat directly, you can jump ahead roughly 2 minutes. I will timestamp it in the show notes, so you can jump directly into the episode. So Rerankers, what do they allow you to do? Rerankers in the end allow you to compare the query and a bunch of documents. And traditionally, this meant basically the document is already in text form and is embedded. Now you can also do the same with images or potentially other types of data or modalities. And you typically see it at the end of the retrieval pipeline. So the retrieval pipeline is usually query understanding, retrieval, reranking. And you embed each document you have in the database. And on retrieval, we get the embeddings, run the reranker on the query and the set of documents we retrieve. And all the reranker tells us is if the query and the document match up. And again, the document could be an image, could be a text, could be whatever. And we are basically comparing the embeddings. And as opposed to regular retrieval, we are not just using an average embedding. So if you embed a document, you embed every token and typically you take the average. In a reranker, you have token level embeddings for the query and for the document, and you calculate something that's called a Maxsim. And the Maxsim basically takes each query's token of a specific query, calculates the similarity of this token with each token in the document, and then takes the maximum. And it repeats that for each query token in a specific query. And then you sum that up, like all the max similarities for each query token, which gives you the score for the document overall. And when you repeat that for each document, you basically have a set of scores, one for each document. And to actually filter down the retrieved documents, you just set a threshold. And documents with scores above the threshold are considered relevant. Documents with scores below it are considered irrelevant. And I think like the immediate question would be like how to set the threshold. And that's a little bit more art than science, but you will hear more about it in the episode. But in the end, it will come down to trial and error. And the base concept you have to understand is similarity. And you can encode anything as similar by creating a data set of input and output pairs which are considered as similar in your specific metric. And the reranker then tries to learn the association. And now we got the basics down, so let's get into the episode. And today we are continuing our series on search. Aamir Shakir is the founder and baker of Mixspread AI, where he's building some of the best embedding and re-ranking models out there. And we will talk about re-rankers, how you can use them to classify, deduplicate documents, score LLM outputs, and also how the cross-encoders like ColBERT, how they work, and how you can use them. Let's do it.
If you want to train on a BERT scale or something, just get 8 A100s and rent them for a couple days and then you can train it. But you're right. So I think it just makes sense. Use BERT, start training it. Even don't use BERT. For example, if you're using embedding models, use an E5 unsupervised or so, which is trained on a lot of data, and just fine tune for yourself. It'd be really stupid to start from scratch. So don't do it.
I'm really curious. How much have you played around with ColPoly already?
A lot, actually. The thing is, we in the team believed a lot in late interaction because it makes so much sense. It's interpretable. You know what's happening. You see the failure cases, and you understand why the failure case is happening. In a sense of you can look at the tokens and how the similarity is happening, right? So you see, okay, hey, the model is confused here and there. So late interaction makes a lot of sense. But so we knew that from a long time, but it has a lot of drawbacks, especially if you start scaling it up, right? Because the token consumption is just extreme. So for people who don't know what late interaction is, late interaction, you do a forward path, and in models, you tokenize every input basically. And normal or embedding models just get one dense vector as the output, where you take normally for every token embedding the mean or just take the classification token, while for ColBERT, you store the embedding for every token. And later, when you want to compare them, you compare basically all tokens against each other. And then you can see, hey, how the token match to each other and how the similarity is, and see where the failure cases are happening. So that's why it's more interpretable. And the issue is, since you're storing all token embeddings, right, it's sometimes 300 or 400 times more storage you need to store them. And also scaling it up makes it, from not only storage but also compute-wise, super expensive. But there are ways to do it better now.
Yeah. And I think like when you can bet on one thing, like storage and stuff like that, it will become cheaper and also we become more efficient at storing the stuff. And especially like EU Bergum is already doing like a bunch of stuff in Vespa with I think like hemming
Yeah,
distances
binary
to make it
quantization.
more efficient.
Yeah, exactly. So the idea there is what we see also. We published a blog post together with Hugging Face on that, and also did some follow-up experiments that you don't need all information stored in those vectors, meaning, first of all, you can get rid of dimensionality by doing something like
Yeah.
Matryoshka representation learning, so you have less dimensions. And also, you can get rid of precision, meaning instead of storing full float 32, you can just store it in int 8 or even just 1 bit per dimension, which allows you then do stuff like hemming distance, which is super fast on modern CPUs because it's just two instruction, right? XOR and pop count. But what we found is that as the performance loss is really hard. We prefer to do more stuff like int 8. This works pretty well. And yeah.
What I'm really looking forward is like the more explainability work as well. When you put like an autoencoder on top of that and actually try to decode like what the different features are and whether they will actually find okay tables or different elements in PDF documents are its own features and basically we can reconstruct it from there.
Yes, it's going to be super, super interesting. But what you can do already right now, just producing a heat map, seeing where the model
Yeah.
has the highest similarity. So later, which is super crucial for a lot of domains to understand what's happening, because embedding models with single vector representation are black box basically. We don't know what's happening. There are some pushes. For example, there was a paper from Google earlier this year where they trained a decoder based on the output of an embedding model to reconstruct the output and see, hey, what's the model representing there? And there are a lot of fun experiments. What happens if you start changing the embeddings? But it's not really, you don't know what's happening. But with ColBERT, you really get this interpretability part, which is really nice.
Yeah. What's an exercise I really often like to play through when I'm building stuff is like how will it look like in 3 to 5 years? Because then you know like how to position yourself in like the best way when you're building something in tech or a tech startup. How do you imagine retrieval and recommendation pipelines to look in 3 to 5 years?
I think it's an interesting question because dense vector representation's been around for a while. If you
Yeah.
think about Annoy as a library for vector search from Spotify, I think was created in 2013 or 2014. So the stuff has been around for a while, and it took so long that the mainstream tech started picking this up, right? I think 5 to 6 years. But the future of retrieval, I wish that we have at one point a compound system which is really good at query understanding and also at multifaceted search. So which really understands what the user wants and tries to find the right context and also ranks this in the right way. Because we have so much unstructured data which is laying around, and it's really hard to make sense a lot of out of this by providing a lot of hacks. And I wish that we have maybe a unified or compound system. We just can feed it in and have nice queries. I think with LLMs, if they continue developing like this, we could have a nice natural language interface to data. And let's see how it will play out and how the architecture of the future will look like.
Yeah, and I think if you think about the standard retrieval architecture, you have like query understanding, retrieval, re-ranking, and the re-ranking part often is because like in the actual retrieval, when we're doing especially like a semantic search, we know that the performance isn't so good. So we have the re-ranker to actually give us more relevant results based on the user query as well. Do you actually interpret it like that as well?
So I think my understanding of this is more, it's a refinement step, right? Because it's more semantic comparison between query and the documents, right? I don't think that the AI model right now are understanding really the queries, because what they do either in the re-ranking step is, depending how they're trained, is finding out for every query and document how relevant they are to each other, or how relevant the document is to the query. And relevance can mean a lot of things. For example, in retrieval step, like how well it's ranked, or if you're try to find duplicates, how similar are they, and so on and so forth. It's really depending how it's trained. But for me, it's more like a super smart comparison mechanism.
Yeah. And if you look at the Reranker, maybe let's go more into the architecture side. What are the different components of the Reranker that actually enable it to basically say, like, the document and the query are
Yeah.
actually relevant to each other?
So let's take maybe one step back and look how a retrieval pipeline looks like to understand really the difference of re-ranking model and, for example, an embeddings model, right? Let's say we do in the first step semantic search. So how semantic search works is you put in data and then like text or image, whatever, and you get an embedding out, which represents this information. And later, when you do a search, you encode your query and get another embedding out, and then you do some distance metric, for example, cosine similarity. And this is a bi-encoder, right? Because you have an encoder for the document and you have an encoder for the query. And at inference time, the model doesn't look at the query or doesn't look at the document. So it just tries to guess a point in the room where the information lays. And then you hope that they lay next to each other. While a re-ranker is more a cross-encoder normally. You can also use GPT for that or LLMs, but let's just stick with the cross-encoder, which is more the classical approach. And what you do there is you put in a query and a document, and then the model looks at both things, the query and document, and tries to understand how similar or relevant they are to each other and provides an output score, how relevant they are, for example, the document given the query. And this is obviously computation more heavy because imagine you have 100 documents, right? Then you have to do 100 inferences for query and document. And this computation is way more heavy than, for example, with the bi-encoder, where you would just encode the 100 document once and the query once, and then do super cheap distance metrics.
Yeah. And have you actually played around with query rewriting for the Reranker as well?
Yeah, we have actually. So it really depends how your model was trained. So, for example, if your model was more trained on question answer pairs, and then you have keyword queries, it will start sucking hard. You should really bring the query in the format how the model was trained, or trained in a way it will be used later. And this was a big learning when we published our first model from user feedback, because we mostly trained it on question answer pairs, because this was mostly our setting with customers and so on and so forth. But people were a lot using it, for example, also for simple keywords and so on and so forth. And then they were surprised, for example, you had a query where the word, I don't know, king is coming in and a document, whereas king, or it's just like king 100 times, but it was not number one, even though it's occurring exactly in there, because the model was not trained for those tasks. And yeah, and for version 2, we are looking into also incorporating this data.
Yeah, and I think to really nail the point home, your data, the main issue in all of retrieval is basically the query and the way the query is written and the document mostly live in different spaces. And your work is actually in mapping those two spaces together or creating a projection from the one into the other.
Yeah, exactly. Yeah, you're totally right there. And it's super interesting to see, because our data is normally super well written, right? You have perfectly written queries, like without spelling mistakes, without like proper grammar, proper writing. But if you look at real user data, or if you think about how you use Google, right? It's like just something super quickly written with a lot of spelling mistake, no proper grammar, not proper casing. And so there you have to really as you're saying, bridge the gap between how your training data looks like and how the user queries looks like. The best thing is having user queries to train your model.
Yeah. Yeah. And I think for me, training an embedding model has probably the highest payoff, especially when I compare it to training your own LLM or something like that. Do you think training a re-ranker has like a similar large impact? Or is like a re-ranker in the end like a component that has a little bit more give, that it tends to already perform well out of the box.
I would say it's even better to train your re-ranking model than your embedding model, because the issue with when you train your embedding model and new knowledge comes up, for example, was trained in, let's say it was a political embedding model, because in politics a lot of things change, or law changed really quickly, and new laws comes out, and you need then to retrain your model so it understands, okay, what did change, and then you need to re-embed your whole corpus, which is super painful and expensive. What we prefer is to fine tune the re-ranking model, because what the re-ranking model does, right? One, it gets the candidates and the queries. It just provides scores, and you're not storing them anywhere, or normally not storing them anywhere. So this means you can continuously fine tune the re-ranking model, also based on click weights and so on and so forth. So I think for us in our experiments with customers, training the re-ranking model had the most impact compared to the embedding model.
Yeah. And I had the episode with Niels, and one of the big issues in embedding models is like long context. And he mentioned like he hasn't seen an embedding model which can handle that. How do re-rankers compare at long context tasks?
So I think they're pretty good at it. So given also our benchmarks, because Rerankers doesn't have this limitation to represent information in one single embedding, right? So what they can either do is actually look at the whole context and your query and say, hey, how relevant is this context to your query? Even though you have, for example, the first passage is talking about Ahoy browser, I don't know. The second passage is talking about politics, and the third passage is the third part is talking about technology. For example, the new iPhone, right? And you ask a question about iPhone, the model still will understand. Hey, the third part is about iPhone, so this context is still relevant basically to this query. In our experiments, actually, re-ranking works really well with long context as well.
Yeah, nice. And do you apply to the re-ranker any pre-processing steps to the documents as well? Like for example, a stop word removal or something similar?
I know we don't do anything like that. It works pretty well without doing this, especially also with stop word removal. That's the tricky thing about here, new neural search and all this modern stack, right? Because the stop word still means something for the context, right? To contextualize it properly. The stop words have a meaning, and it's pretty relevant for the model to understand this as well.
Yeah, I think stop words have become one of my biggest pet peeves because I started to actually look into the stop word lists when I'm doing NLP pipelines, and you can imagine like what kind of biases are like in the stop words list. And most of the time, when you use them, you should create a custom one.
Yeah, but I don't think, I don't know if you have seen it, but I don't think it's worth the time investment, because the models are trained on such a variety of data. So let's say understand what's relevant and what's not relevant. I would just feed it in.
Yeah, likely you're rather causing a performance downgrade because your documents suddenly are not as similar to the training data.
Yeah.
That's so interesting. And in a re-ranker, especially when we're in a corporation, I think e-commerce is the prime example that you often like to add additional factors to the re-ranking model. What would be your decision process to decide, for example, I have the timeliness of the item, like it's like a new one and I want to rank that higher. How would you actually add in like the decision process to decide whether I try to encode it in the re-ranker, where I actually just rank in my training data set, I prioritize items that are newer at the time, or so it actually learns like some kind of semantic similarity, or I actually add that as an additional factor in the end, which can be added just basically as a score for prioritization.
Yeah, so unfortunately, the answer here is always it depends, right, on your data and your use case.
Yeah.
But what we found out is that re-rankers are really good in understanding also structured information within, for example, your input. Imagine you have a JSON field, for example, where you have a bunch of metadata as well, and you train the model to understand this metadata. It's really works really well. You could put it in there, but again, you have to specifically train your model for this. But if you want to use just an out-of-the-shelf model, then it's smarter to do it in the end and just do weighting. But
Yeah.
for example, this metadata stuff helps also, for example, do recency stuff, right? So because you can't really put recency or like the date into embeddings, you could we tried it. There's a hack. So you take the vector, and then you encode the date as 2 dimensions in the end. Then you just do dot product in the end. So you add it also to the query because this will boost it up, right? The later it is. So that's what's done in recommender systems. But we found that adding it to structured data in the Reranker works really well. But you have to try it. And if you can, or if you have a post-processing pipeline, just use this.
Yeah. And how do you actually represent it? For example, if you have a date, you likely have to put it in the query and in the document, like what is the current date. Did you represent it as like an actual timestamp or
We just put it
as
in
a
time.
JSON?
A
Yeah.
day. We have really a JSON. We
Yeah.
put in JSON structured information and just put date double point, for example, in. This works pretty well.
That's really interesting. What other experiments have you run with like different representations or additional information to add
For
to?
example, pricing. For example, hey, I want an iPhone below $500 or a phone below $500. It works really nice. What we also try to push is that when you, for example, search for stuff like emails, you normally want to have the most current ones ranked up. And we just wanted to build a compound system instead of having filters and doing. Actually, what I really don't like about current systems is that you have so much hex around it, right? So you need to do metadata extraction. And this sucks. It doesn't work well. It's painful. And what we try to really is really incorporate into the model so that they try to learn or understand that and then just put out the right output.
Yeah. So it's getting easier, in my opinion, with LLMs to do all the like metadata or field extraction to do faceted search and stuff like that. But it's like you have to be way more explicit and you're less flexible in the end.
The thing there is also you have to sit down and then really nail it down for all different edge cases. That's what we find painful, especially if you have a lot of different data sources and your data sources are not unified. Think of a retailer who has maybe 100 different ontologies from different providers. Then good luck, have fun, really unifying everything and extracting it in a nice way. And we found like having a compound model who can do that is a really compelling solution.
What are like some of the more creative ways you actually have seen the output of a re-ranker use?
Yeah, you can use it for stuff. You can use it pretty well for classification, for example, for zero-shot classification. Works surprisingly well. For deduplication, we see a lot of people using that. For LLM output scoring, so this works also well, for example, for routers to figure out which model to use. Works really, really well. Actually, as I said, for me, it's cross encoders, for example, are a really smart way of comparing things, and there you have millions of use cases how you can use it.
How did you use it for zero-shot classification? So what are the inputs, what are the output?
Yeah, so the input could be, for example, like your document. Uh, and of course, you have to tune it for this a bit, but your other output could be the label. And then you just see, for example, from all your label, what's the highest score, basically, and classify it to that.
Yeah. It's so interesting. Have you ever played like it doing keeping the same query? So, for example, always having the 5 different classes you actually have in your classifier, putting them together in the query, and looking at it whether they are like different, like a single token in your model, and actually using the late interaction scores
Oh,
the text has with each of the singular tokens to actually use as a classifier and taking the token which has the highest score.
no, I haven't tried it yet, but this sounds like a fun experiment to do.
Yeah, you only have to find like different tokens which are unique,
Yeah.
and then basically map each class you have to one token.
Yeah, it
And
has a lot of unused tokens for this, exactly this idea that you can do experiments like this.
if you want to do that, I would be up for it. I think that sounds like a really fun experiment.
Yeah, I think maybe one of the listeners could do that. It sounds actually also like a cool project for an internship or so.
Yeah, master thesis.
Yeah, let's go.
Nice. And on the other side, like at the moment, what I'm using often in production is using NLI models to actually determine the factuality.
Hmm?
Is it, have you worked more around that aspect as well, and how would you actually implement it to use a re-ranker to check whether the relevant information is in the source data for a given statement?
I think cross-encoder is the way to go here. There was also a paper last year, I think, where they did exactly this, use a cross-encoder to align scores between the documents and the output of the LLM and the factual documents, and to basically add citations. So they iterated basically over every sentence, I think, and then provided the score. And if it was above a specific threshold, they say, okay, hey, that's the citation, or if it was the highest score and above a specific threshold. And you can perfectly use it for that.
Yeah. How do you actually think about tuning a threshold?
Yeah, it depends always on your use case, right? I find it always fuzzy. I'm not a big fan of that because it feels somehow the model should be able to reject something, right? Or there should be some mechanism where we know if it makes sense or doesn't make sense. Because we found sometimes, hey, even if it's below a specific threshold, it still makes sense, the output, or it's still relevant. Then maybe your threshold is wrong. And threshold tuning is super hard, but I don't have a perfect solution for this yet. But maybe in the future we'll figure out how to get rid of this hack.
Yeah. And the part where we're moving more multimodal, I think we already touched on ColPoly. Do you imagine we will be adding more and more modalities to the re-ranking part as well? Because I think that's where I'm very torn in audio. Because in audio you could do it, but it's just way more convenient to actually just translate into text because it has a one-to-one mapping.
Yeah, for audio, I think it makes sense to map it, but what about geospatial data, for example, like
Yeah.
satellite imagery and so on, or like data in biomedicine, where you have a lot of different formulas and so on, where it would make sense, where you can't really translate it, but you still need to retrieve it or rank it or whatever for your drug discovery use case and so on. I think the future will be multimodal. We I hope we will have a compound model which can do all modalities, basically. So one supermodel, I think Kopali, not the model itself, but the idea and the paradigm is, I think, the way to go. And will be really interesting how we can add new data in the future to that. And also multimodal re-ranking is going to be super relevant because you basically can reuse the adapters or exactly the same idea as from Kopali, where you have three different encoders for different modalities, and then one world model, let's say, which in this case LLM, which does the real computation, and then you can use for re-ranking, for example.
Yeah. And if you would take like one use case, for example, the biomedicine,
Yeah.
like you pick a new domain, how would you actually go about creating a data set that you can actually add the new modality?
Yes, I don't know how it specifically looks like for biodata. Then let's maybe do geospatial
Yeah.
because I have some more experience there. Yeah, for example, you want to do poverty prediction, right? Let's say poverty prediction. And you have a map or a data set where you have, for example, how poor the country is and the region, right? The region and their total consumption per year. So you could then construct a data set where you can ask, hey, what are countries or what are areas? So bring it back into the QA data set, right? Where it's below a special or a specific threshold, or what are poor countries, and then you can use a rank and basically use them as an answer, and then use the technologies we already know, like constructive learning or ranking laws, etc., to train this model. And what you need to do is basically you need a mostly satellite imagery is hyperspectral, meaning it doesn't just have the three channels, it has mostly 7 or 14 channels or something. So you need an encoder which understands that. So maybe you can here modify your image encoder, you train it so it understands pretty well. So this you freeze then, and then you put it through your vision encoder, hyperspectral vision encoder, get embeddings as output, and then you can feed it into your LLM or whatever encoder model you have or decoder model you have to then generate embeddings or whatever you need.
What do you think is like the trade-off between different embedding spaces and a joint embedding space?
I think it's aligning also the output of the distances. For example, if you try in Copali do image to image search, the scores are way higher than trying text to image search. So basically, it's really not trivial to align those vector spaces, but there are work about this, how to do it properly, and so it's doable. But I think it's way better than having 5 different indexes for caption, description, like above the image, then the image itself, and then some other random stuff, and then try out some wild weighting schema or ranking schema to merge them somehow together. So I think having something like ColBERT or like a joint embedding space is a way more compelling solution.
If we were to add on the thread we were on before, if we were to add an additional modality, is it more prudent to actually train a model from scratch, or can an additional modality be added to the embedding space through just fine tuning?
I think a modality can be added pretty nicely. So I think what needs to be done is a bit pre-training again on the model layer. But as we know, for example, with all those audio models popping up, it's not so hard to do. So you can do it with not so much data. And then you basically just need to fine tune it for your retrieval use case.
Yeah. What do you think, like a new modality, what new signals does it actually bring? If I already have, like, I have audio data, I have image data, and I have text data. And now I add, instead of using the text representation of audio, I'm using the native representation of audio and bringing it into the embedding space. What is actually my benefit of doing that?
I think it's the diversity, right? So you give the model a better understanding of the world around. Or for me, LLMs are of course like language models, but also small world models, which tries to modulate the world as good as they can. As we can see, also if you just add image or video, it works, right? It works really well. Also, if you add new stuff, you just make the model better or the understanding of the model better. And also, what we figured out is that the modalities support each other. For example, if you train a model just with images, it's also pretty good at text retrieval. And I think what would happen is that the more stuff you add, the diverser the representation gets, or the better the understanding of the model around it the world gets. And this will boost basically the performance in general of everything.
Yeah. Do you think we actually make it also harder to, like, the AI person who takes the model and wants to fine tune it, make it harder to adapt it to the specific domain?
In a perfect world, we don't need to adapt it, right? But we're not there yet. But I think you would make it harder. But I think it would be smarter for the AI person just to pick out the two modalities or three it needs. You rarely need all modalities, right? You can just basically ignore because if you think about it, you never tune the encoder part, right? You always tune the LLM or like the representation model part. So and there you do LoRa training, and it doesn't matter what you input. So the training stays more or less the same. So if you just have text data, as I mentioned, what we figured is that also the audio performance will increase, for example. So the different modalities will also improve by just having training it on one modality. That's what our first experiment showed. But yeah, it's a bit more flunky to work with them. So I think this is a bit more painful.
Yeah, I'm at the moment setting up a data set for ColBERT for basically doing more table retrieval, and then like finding the relevant things, and then also training a vision model for doing the table extraction. And it's very interesting, like the amount of stuff you can do, but also the synthetic data generation part is so interesting because you can now, especially with O1, you can easily just fake the data.
Hmm?
And how do you think, like, synthetic data generation, how will it impact, like, also like your work, and are you already experimenting with stuff around that?
Yeah, so I think with synthetic data, you have to be always careful. Either you generate your training data synthetically or your eval data, but not both.
Yeah.
That's a bit of our learning because you then just sample from the same distribution, basically, which is not your real world, real user distribution. So you have to be super careful there. But of course, synthetic data is going to be the way for a lot of niche domains and also general the way to go. What we do is we have more a mixture of raw data, which we get through open available data, web data, and so on and so forth, and also synthetic data, obviously. But we try to have a nice balance because it's just more diverse, and we hope that the model generalizes better.
Yeah. And do you have something you're shooting for? I talked to Niran, for example, and he mentioned like he wants to have like at least 50% of real data to this.
No, it really depends on the use cases. So we just see what works. I think having hard numbers there is not a good idea. You should always look at the use case. For example, if you're in a super niche domain, So you may be happy that you can get 100 samples or so, or 100 documents, and the rest you have to generate synthetically, for example, through few shot prompting and so on and so forth, and then saying, hey, I want at least 50% of raw data. It's hard.
Yeah. How have you found any approach to actually check whether the document is still in distribution of the domain you're sampling from?
Yeah, manual checking, right? So reading through it. So that's, I think, that's what's missing right now is proper tooling and proper just tools to check those basic things actually, right? Because this decides if the model is going to work or not, or if your work is paying off or not. And it's somehow shocking, but it's also hard to create those tools. And I think in general, we need better tooling for those things.
Yeah, I think it in any domain at the moment, or anything of whether that's embedding models, re-rankers, LLMs, like the way to go is look at your data and the whether you have like synthetically generated data or new data. What's the input? What's the output? Read through it and create a data set that you can use for evaluation and also for training.
Yeah, exactly. That's the way to go. Unfortunately, it's pretty boring compared to, or I'm keeping my GPUs busy. But I think that's the most relevant part, and that's the part where we spend the most time in.
Yeah. What's missing from the space? What would you actually say more specifically? What's missing in the retrieval space at the moment?
Mhm. So I think a way to generate good evaluation data, because nobody wants to do that, it sucks, and that's missing. And also maybe a tool to measure data quality for your from your training data and check stuff like, hey, is it in the distribution or not? I know there are startups like Womp Labs and so on who are working on stuff like this, but it's going to be really exciting if we can solve those issues.
Yeah. And what is actually like something that you would love to see built specifically that would make your work 10 times easier?
Huh. Maybe a data miner for everything we need for every domain. So you can just write in, hey, give me data for domain XYZ. It should be multimodal, it should be this format. And I just get my 10 million rows. This would be
Yeah.
pretty nice.
Yeah. Nice. And if people want to start building the stuff we talked about, like where would you point them?
Obviously, this podcast, right? And I think the Twitter profile of you is a good starting point. Read through our blog posts on our website, and also from Tom Arson, the posts on Hugging Face and the Transformers, sentence Transformers documentation is a really good starting point.
Yeah. And for you, if people want to get in touch with you, hire you, stay up to date, where can they do that?
It would be obviously Twitter, LinkedIn, and email.
Nice. And I will put all of that in the show
Yeah,
notes.
this would be great.
So, what can you take away for our applications? I think re-rankers in general, even if you take, for example, coheres, are probably one of the biggest boosts you can add to your retrieval system without fine tuning a model, because out of the box, a bunch of them will work well for a broad set of use cases. So if you don't have them, I will give them a shot and see how they end up. At the same time, I think re-rankers push us down a little bit in the same direction as embeddings does, that we don't really think about how can we actually map the query into the same space the document lives in, and which kind of documents are actually relevant for a given query, or which queries could be used to retrieve a document, which often helps to build like a good retrieval system. I think it pushes us further down that road because we rely more and more on AI and less on how we engineer the system. And this isn't anything against re-rankers. It's just I think you have to strike a balance that you don't have an over reliance on AI models as they are more of a black box, even though re-rankers are more explainable than bioencoders or regular embedding models. For me, the most important part to take away is that looking at your data again is a massive part of building good models. And especially if you want to integrate a Reranker, look at the training data that was used to train the model. Or if you use a closed source one, so for example Cohere's, look in their docs what use cases they're advertising it for. Because if your queries look very different from what they're advertising, or also what the model was trained on, it's very unlikely that the Reranker will return any good results. And then you should be careful. For tuning the threshold of the Reranker, I think you should train the Reranker, look at how it scores your test set, and try to find adequately well-working threshold. Otherwise, the one more really interesting part is encoding JSON or putting metadata into the document as well. For example, in news item could be one where you add the timestamps. So the model learns that the more recent the item is, the more relevant it is. And here, I think that's really interesting because you can play with many different encodings. So if you have the timestamps, you could use the actual timestamp and add the timestamp to the query as well, so it can see like whether it's identical or not. But you could also do something like, for example, you could add like how long ago, like a delta instead of a timestamp. And you can think out like many different ways to encode the same piece of information. I think that's very interesting. And also in stuff like, for example, like in e-commerce, if you want to prioritize high ticket items, but only for a certain set of queries, whether it will actually work when you put the prices of the items also in the data as well in the document. And I think that's really interesting. Yeah, next week we will be diving deeper into ColBERT specifically with Bergum. And I'm really excited for that. If you want to catch that or stay up to date with any episodes, subscribe. Otherwise, if you have any feedback or if you didn't like anything or if you want to hear about a specific topic or from a specific guest, just let me know in the comments or shoot me a message on LinkedIn. And yeah, I will catch you next week.